Good evening, everybody. All right, today's box is Unbaked Pie on TryHackMe. Pretty interesting little box. Has to do a little bit with Python, Django, pickling, which is a kind of a new concept for me, but it's serializing data and then unserializing it in Python. And then once we get access to the box, we're going to look at trying to, escalate our privileges and move laterally, get some more access to the box there. So this is a challenge room on TryHackMe. It's a medium box. The only guidance that it gives you is a user and a root flag. So they're looking for you to kind of be able to lead yourself on this box. So again, sticking to your standard methodology will help you kind of get past some of the loopholes. So we'll do what we normally do here. So we're going to get into our directory. We're going to put our target IP address into our targets file. And then we'll go ahead and start our nmap on that. So we're going to do nmap-il, which is input list targets. We'll do a -t5, and we'll do -08 init scan. While that's running, we'll go ahead and get a more detailed scan running so we can see if we can get any more information out of that while we're waiting. So one of the quick things I noticed about this box is that not a lot of stuff comes back when it does scan. It's not as quick as some of your other boxes that you may have played with. And we'll see that here in a minute why. But that kind of gives you an indication that you're going to be looking at a little bit more advanced stuff. So we only see one port come back. It's 5003. Alright, so we're going to also do the input list scan T5 script default version and HTTPS or HTTP. Again, we're going to see if there's anything running on that. Script timeout is going to be 2 minutes. Output all format script scan. We'll have that run. We'll look at the port and see if we notice anything. Okay, so we do get a website, some kind of blogging type website here. So we'll go ahead and get our default tools running in the background to kind of see if we can find any hidden directories, any of that type of stuff. Again, you want to kind of have some of your more intense recon running while you're playing around with the site. Nmap came back with not much more added onto that, so really didn't help us out. So we're going to do user share. Directory buster, and then directory 2.3 medium. Let's go ahead and figure out what kind of site this is. So the way you figure out the underlying technology is this. Whenever you get the website loaded up, you try to do like index.php. We don't get something, but we do get a weird error message. So this is something to kind of note here. Using URL config defined in bakery URLs, we see that Django tried accessing these URL patterns in this order. So admin, home, share, search, about, slug, accounts, static, media. So it's interesting. Again, this is kind of giving you a little bit more, way more detail than you should ever get. We are able to see that this is Django and it is running in debug true. So this is some indicators of things that we need to play with later. So we did not get index.php, so let's try index.html, index.py. So we're not getting our standard web pages, which is interesting. So we'll have to play with that later and see what underlying technologies is. The reason we were looking for that is that we could also specify file types when we're doing GoBuster to see if we can get any other additional file types. So we're going to have to stick with just the list right now, and then we'll output that as GoBuster results.text. We'll have that go from there. All right, so with GoBuster going, we can kind of play with the site. We see that it's called Unbaked. Share your recipes, why not? We see that looks like some kind of pie website, a little bit of a blog type template. So it's probably reading in information and then rendering it. We're not seeing a specific copyright or anything like that. So the other thing that we could do is look at the page source. So let's blow this up a little bit and see if there's any comments or anything that kind of leads us into the direction that we need to go, right? Like, what is this? What's the underlying technologies? So we do see that they are branching off into different areas of the website. Again, nothing in the comments or anything like that for our CTFE type stuff. So when we click older post, what we're looking for in the URL bar is to see if this is, putting something else in there that kind of indicates that, maybe we have a PHP or something like that we can exploit. We're not seeing anything there. We see home doesn't go anywhere. About does go to a different section. Nothing really there. Comes out. Search, we can do a test. We can click search. Again, we see search. We don't see any test results here or anything like that. We could look at the page source and see if we get test. We see that the document is expired, which means they're not caching the document. So that means, cross-site scripting or anything like that would be a little bit harder to get. We are getting some information by looking at the source, though. We do see a Python executable. We see that it's a user local bin Python 3. We're getting a Python version. We're getting a path. There's the server time. So again, we're seeing what version of Python we're running. We're running Django. So we see that there's some errors handling here, Django handler. So this might get flagged. This type of error page or whatever would get flagged for verbose error messages. So this is interesting here. We see encoded cookie equals base64 dot base64 pickles dump query dumps pickles, encoded cookie equals encoded cookie dot decode UTF-8 if query results equal article objects filter q title contains query q body contains I contains query else results equal article objects all. So we can see here that it's basically reading some type of code from our cookies. What we could do then is look at our cookies via our cookie information. I might have to go to the normal page here. There we go. So we can see that we do have a cookie set. We have two of them. We have CSRF token cookie and our search cookie. The search cookie is more the interesting one because when you look at it, this looks like base64 data. Again, the good indications of base64 data is anything that usually equals ends up having an equal at the end or equals at the end. These are usually tell signs that something has to pad out to base64 for that to work. And so the way that we can validate this, right, is doing CyberChef GitHub there it is. So CyberChef allows you to kind of paste data text in there and put multiple different little filters on here to kind of see different things. So what we want to know is from base64, what does this look like? And we are getting a test data, which is interesting here. So if we tried something different, like hide from search, and we do that, we see nothing appears on the page, but let's look back at our cookies again. So we do see our search cookies changed. It is different. Again, there's no equals on here. It didn't need to pad that out, but so we see right here that it decodes the hide from search. So the application is taking our input and doing something with it, which is pretty interesting. We noticed here again, the comments kind of lead us a little bit. Pickle dumps query. It's using that encoded cookie. So, looking at the error pages, again on the main page you're not seeing this stuff, but on the source code underneath it, this is where you're kind of seeing what's going on. So we have some big information out of this, right? Like we have that we're encoding a cookie using base64 and pickle. And then moving on, we see here that it's using Django. Here's some other errors that are coming up. There's the cookies it was signing, stuff like that. Listing of a server version. There's some databases that are listed out. There's a max size for databases. So yeah, I mean, you're getting a lot of information by just looking at the source code here. All right, so what do we do with this, right? Like, how do we exploit this? Let's double check, make sure we haven't found anything about and share. Those are 2 pages I think we knew about before. So we had about up here. We did not have a share, but these are search, so we can see what share does. Looks like you need to log in. We could try some default creds. Please enter a correct username and password. Note that both fields are case sensitive. Inactive, they count as inactive. So this kind of provides you a little bit detail too. If we look at the source code of the page, we could see if, again, that gives us any information in the comments or anything like some of our other CTF boxes, but it does not. So I remember reading about Django and pickling and serialization and deserialization attacks, and so this again just is part of being up to date on what information is going on, what things happen in the industry, and how you could end up using those to your ability, or just kind of putting those little bit of pieces of information in like the back burner, right? And so I remember specifically that pickling was kind of exploitable, and the way that it was exploitable is the way that it unpacks that serialized data and then kind of executes it. And so if you kind of Google Python and pickling and Django, you'll eventually kind of come to this article here from David Harmon, and he writes about how to exploit Python pickles, and he really goes into really good detail about what this is. And so just to give you the super high level of it, is that in Python applications, sometimes you want to serialize data, and what serialized data means is just you take all these different like strings and values and numbers and different types of data, and you just want to put it into a string. And that string is then what you're getting to use instead of, specifying numbers or types of strings and things like that. And then, here it talks about not every object can be serialized, such as file handlers. And so then that comes with restrictions and such like that. And he breaks it down into, you could create a method that gets pulled in, and if that method gets pulled in, then you can basically cause an execution on the system, because once that gets depickleized, it runs on this system, and you can exploit this. And so here he is breaking out the basic exploit of this, and what we're looking at, right, is that he is taking the command and he's doing remove tempfs, make file in and out in tempf, and then cat tempf, and then pipe all that to bin sh-i, output the standard out or standard in into the first pipe through netcat on 127 port 1234, and pipe that into tempf. And so this is a netcat reverse shell. What we then see is that he's returning that OS command, OS system /command, and then we are pickling that data and then printing out whatever the base 64 information is. So it's pretty powerful. We could use this, and we could start with this as a basis and see if this is something that we can actually even do, right? So let's open up Visual Studio Code. Let's just do a new file. We'll put that code in here. We're going to go ahead and save this code into our directory that we're working in. All right, instead of this, let's see if we can just have it push. Hold on. Visual Studio Code wants to tell me that I need to pick a Python user and all these other things. So before we do all that, let's just see if we can execute. Who am I, right? Like, let's see if this actually is even going to execute stuff before we get into all this different, type of reverse shelling and trying to get anything past that. So we'll save that. This is saved on there. So if we run this, then we should be able to just should get that base 64 output, put it in the cookie, and see what happens, right? Okay. We need it. So what I'm trying to do here is change the modification to put this as execute for that test exploit, and then I'm going to do that. Okay, so import not found. So what we did not do is what we should do with our Python scripts is put in where our Python's at, so it knows which one to use. User bin Python 3. Okay. There we go. So this, if we put this information in our cookie, what we should see on the output then, or what we should see is somewhere in that source code, right, is the output of this. So let's see. Let's go back to the main page where we were searching for stuff. This is where we were finding this test, and we put search. We can try that here and see if we can see if that comes back with anything. That came back more with just our base 64 code. So let's put this in the cookies and see what happens. We'll need to load the view cookie information, edit this. Okay. Try to load that page again. So we're not getting anything. So we're not seeing stuff, and that's probably due to the way that, we're having to play with this application. So what we need to do is we need to implement burp in this instance, right? Like we need a proxy to basically be in between our browser and the web server, and then getting that information back. So we'll move on to burp now. Again, I'm using Burp Suite Pro, but you can use the free version. Nothing I'm going to do is different than on the free version. All right, so if you have not installed Foxy Proxy, I'd highly recommend installing Foxy Proxy. It allows you to kind of quickly change your options on your proxy settings. In this case here, I have burp set up basically already. So when I click the search, we can see here that it brings up burp. We see that my CSRF token is already here, and then my search cookie. So for my search cookie here, what we're going to do is just put that base 64 data that we got from here and see if we get any information out. So again, what it was doing is base 64ing my data, so it was not giving us anything that we needed there. So this is the response from the website. We also see that we do get some kind of error message here. Results reference before assignment. Let's see. So there's our search cookie that we're trying to inject. So we are seeing a host. The password is asterisked out. There's nothing in there. We do see that it's loading a SQLite 3 database. So again, that's pretty interesting. So the only reason we're seeing this dedelled information is because that they have debug equals true on their Django settings, which is not the best thing ever, of course. All right, so we didn't get any information that we're looking for here. Looking at burp, we would be expecting to look at like dub data. We see prepend dub. It could be root if that's another way. We do see root. I think root was on the other page too. That's what this is running as in the home directory. So we're not getting much information from this. We could try a different approach, right? So another thing we could do is we could execute a command on the system that would contact our system, and so that then we know we have some kind of code execution, right? So whenever you're doing these type of CTFs and stuff like that, you're usually VPNing into them. So we want to do like a TCP dump -I. And this is going to be ton 0 for our ton interface, and we'll do a --v. So this is going to be very verbose. We'll see that, hey, look, we're getting a lot of stuff back, especially on this 553 or 5003. This is the port that we're communicating at right now. So that's not going to help us, right? We need to clear this up a little bit. So when we do that, let's think about the attack that we're going to do. We're going to maybe have it instead ping us, ping our IP address, or try to do like a netcat or something like that. We want to see if it'll communicate with us, right? So first thing to try is ping. We'll do a ping. Let's do maybe five pings. So C5. And then we need our IP address, and this is going to be on whenever you're logged into TryHackMe. If you load up the page and you're on the Open VPN, oh, that's not going to work. That's fine. We can just do it this way. Config ton0. So there's our IP address. We'll do this. So now it should ping us 5 times on our IP address. And if that happens, then we know that we're getting some information back. So for burp, we'll just do this. We'll do the intercept off. And now what we'll do is we'll reload this page and we'll intercept the cookie and then replace it. So let's get our new exploit. Okay, we'll see this is different than before. Okay, we are listening on ton0. We're going to listen to ICMP. We'll do verbose. Okay, so we're listening. Nothing's happened yet. So now we'll intercept this. We'll click search. We want to take the search cookie and replace this with that ping command. And we see that we are getting something. We are getting something from 10.10.107.603, which for us is the IP address of the machine. So we are able to execute code on this machine. So this is a good indication that we have ping where we're able to receive some kind of communication from there, and basically that that's available to us. Again, we do get an error message stating back that there was an error from the machine, but that's probably just because it just doesn't know how to handle the web page, right? All right, so with that said, now we know that they're executing stuff, that we're getting that, and we just need to see if we can get anything to kind of connect back to us. So if we can get some kind of shell on the machine to execute, then we can maybe move further. One of the things we want to try first is because we know this is Django and we know this is Python. Can we get maybe a Python shell running, right? Like what does that look like? So let's turn this off real quick. Let's look for Python 3 reverse shells. So payload all the things is coming up on this one. So we'll look at Python. All right, so there's this one right here. So let's try this and see if we can get this going. So we need to change the IP address, right? That's not our IP address. Port 4242 is fine. We're going to do a Python-C. Everything else looks fine. So we'll save this file. Let's go ahead and clear. Something didn't happen. So we're breaking some kind of all right. So what we're seeing here is that the double quotes and the single quotes and stuff like that are kind of breaking things. So what we're trying to do is convert this to make sure that this is right. So now you see everything is in a comment section, encapsulated. So let's try that and see if we get. All right, so there's our big base64 data now. Before we execute this, right, like we need to get our shell listing. So let's go ahead and cancel this one out. So we're going to do a netcat LVMP 4242. So this should be listening on port 4242. This is the port that we're specifying here. We have the base 64 encoded data. And what we'll do then now is we're going to intercept this request. We'll need to turn Bert back on. And we're going to reload this page. So we see this is a search. We see the search cookie. We're going to replace that search cookie with that base 64 data. So hopefully we'll get a shell. If not, we can go, an easier shell. Okay, so we're not seeing anything. Close that off, see if that comes up. Okay, so nothing there. So it might have been too complex, might have been just not hitting the right things. So let's just do the standard like bash shell or things like that. We might not be able to execute Python inside of Django there. So we can do the standard standard bash shell. So this is it right here. And we also might have escaped characters too because we have these single ticks and stuff like that. Again, it's usually harder in these situations where you don't know what you're hitting exactly or how that's being decoded. So this is why we play and test around with this stuff. Okay, so that should be good. So we'll save that. We'll try this again. This is our new base 64 payload. So we're going to copy this. Again, we'll reload that. That should, whoops, we did not have intercept on. So let's go back to the search. And we'll put the cookie in here. Forward that on. Turn off intercept. Might have not got a good call. So let's just go to search page and see if we can get something without messing this up. Okay. Let's intercept this again. We'll put the payload in there. Test. All right, so we're not getting our shell back. Let's play with a little bit more with this and see what's going on. All right, so we're trying to do the bash I shell. IP address is right. Let's try to do another way sometimes that you need to do this is bash C and then single tick this and close that out. So that spawns off a bash shell to do this. Sometimes that's needed instead. Okay. So you notice again it's going to be a little bit longer. Let's put the intercept on. Okay, there's the cookie. Forward that on. All right, so there we go. We got a shell now. Again, just a little bit of playing with it, trying to figure out different ways to get that going. So now that we have some kind of access on the system, let's see, where we're at, what's going on. We do see that we're root, which is pretty crazy for a system that you got root immediately. So if we look at ls, DLS LA, we do see that we have a .git, .vs, code, requirements.sh, run, and site. So we could look at the .git and see if we get any more information out of there. We have a half terminal, so again, me pushing arrow keys is what's causing that $D to show up. So we do see some Git information there. So it looks like this project was maybe cloned into this, so we could maybe do like a Git digger or Git a Git pull basically to kind of see what's going on, what the full information is around that. Let's see what else. Let's go ahead and see if we can get linps running, because that really would probably make more sense for us to see all the different avenues. Again, I CD'd into temp. We do see that F directory. That's that reverse file that we tried to do. We do see a payload.elf and a socat, so that's interesting. All right. So for us, we need to do opt dot let's see, we're going to do tools, no, privilege escalation. Oops. So that's our linpies. We'll clear this. We're going to do ifconfig ton0, and then we'll do Python 3-m. Okay, so that should run the web server. We'll then do a wget. We're going to do http 10.2.12.219. And we are running on port 8000. And we're going to pull linps. Okay, you see that it pulled linps here. And now it saved it. So if we look at the directory again, we still need to put the execute bit on there. So chmod plus exe, or the execute bit, and then linps.sh. Okay, so now we have that going. We could do linps.sh. We could tee that off into results.txt, and let's see what that's going to come up with. So again, this is identifying us as root. We can really see if that's going to happen. Still good to kind of see what we're at on this. It is noting an older version of Linux. It is also a weird host name. If you notice that here, this should kind of indicate something to you. Yeah, most host names are not going to be that, so that should be an indication of that we're not in normal territory, as I put it. And we'll see when linps gets finished up here. All right, we can see linps is running off, so let's look at some of this stuff as it's still doing its thing. Again, we indicated that we are identifying an older version of Linux. We are picking up some paths here. Picked up the date, some mounts. We see that we're in x64, genuine Intel. We pulled out the environment variables. Again, we do see that weird host name. Do see a Python pip. We do get a GBG key, which is interesting here. Something to maybe think of later. Python version. And then, is this a virtual machine? Yes. Is it a container? It looks like we're in a Docker container. So that would explain more why we're having that weird host name. We do have some additional useful software. We have compilers installed. Here's our processes. We see that we're doing a run.sh. Python is running a manage run server on that port 5003. We see our shell that we ran, and of course linps. What else are we pulling? So we are pulling, there is some network information here. We are also on a 172.17.02 network, as well as a 10.0.0.0.2. We are getting a neighborhood and networks IP address of a different one of the subnets. So again, on a Docker system, if you're running a Docker container and you have like a database and something else attached to it, it's going to create its own little network and attach itself to it. And it's usually, again, this 172 network, 172.17 something. And this is just to kind of keep it so that that's accessible only to the Docker container. So it's good to kind of know. Again, we see that we're running as root, things like that. Anything else that we have in here? Let's see. We did find that there is a readable MySQL myCNF. So that might be something we might want to look at. Password hash for SSHA to structural, known hosts. We have private SSH keys. Again, those are probably just the ones in the container, so might not be usable, but it's something to look at, right, and look and understand. We do have writable privileges over stuff in Etsy. Again, we're our root, so you own the script user bin get text.sh. You can read the shadow file. Passwords WD is writable. So some big things on this container, like when they ran it, is that they shouldn't have ran it as root. They could have ran it as a different user. Do have a bash history file. It does have some kind of information in there. We don't have a Python history. We do have looks like files in our home site directory. Found interesting column names. So they did find a SQLite. So there's a password, a hash password, but that's PBKDF. That, if I remember right, is one of the harder password hashes to crack. Give me 1 second here. Copy. Let's turn off burp. Password-based key derivative. Yeah, so it's not like it's a standard hash that would be pretty easy to kind of get through. We could play with that as more of a last resort type situation. We do have some SSHing into the other host from here. We are pulling out some password files, or trying to pull out password, looking for passwords in certain things. So let's see, we see here different things that it's pulling out. So we're still waiting for this to kind of finish up and see if we get anything else out of this. So we'll want to look at our bash history a little bit, see if there's anything in there. We'll want to look at the .ssh directory, see if we have any creds or anything like that. And then we could scan the Docker network and see if there's other, we know that there's other instances running, but where are they at? If it's just that one or a couple of them. So we'll have to see that. So LinPeas is taking its time. It's the only problem with having